Greetings for the day. My name is Divya. I am a part-time research scholar of Bharatiya University. My topic for today is artificial intelligent models for automatic diagnosis of fetal cardiac anomalies. It is a meta-analysis. So I'll first introduce what is fetal cardiac anomalies and what are CHDs. The congenital heart diseases, the short form is CHDs, which is a very common term most of us have heard, but this can be very severe as well when it comes to the heart diseases, and when it is basically happening to a baby, it is going to be very severe. So, congenital heart diseases, it is a general categorization of any malfunctioning of the heart. There are range of CHTs which could affect the normal functioning of the heart. So this is a general terminology that normally we use. So congenital heart diseases are being observed when the child is in the womb itself, and this is normally diagnosed during the of second trimester scan, ultrasound scan. So the three scanning is mandatory during the pregnancy. The first scanning happens in the first trimester, second scanning in the second trimester, and the third scanning in the third trimester. First trimester, the overall health of the baby and the growth of the baby will be observed. In the second trimester, the anomalies, any anomalies in any body part will be observed, and in the last and final ultrasound scanning, the position of the baby and all the other things, before birth has been observed. So CHDs are normally found during the anomaly scan, which happens around the fifth month of pregnancy. And this is there are so many other types of anomalies as well, but CHDs has its own importance because it is the least diagnosed uh, anomaly uh, when compared to the other anomalies, and it is the most occurring also. So the statistics says in 1 in 100 childbirth, uh, one can be observed with CHD, and we can broadly classify CHDs into two. The first one is the normal CHD, and the second one is the critical CHD. Critical CHD can be shortened as CCHD, and where critical CHDs are cases where immediate medical attentions, immediate surgical corrections are required. Sometimes what happens is, even after the diagnosis, we or the medical practitioners can give appropriate medication so that baby can survive throughout the pregnancy, and once it is born, immediately the surgical corrections will be done. So that is CCHD, and CHDs are normal CHDs. Sometimes it might not require any medical supervision as well. Sometimes during the time period on itself, it'll get corrected automatically with time. Sometimes we need slight medications and medical supervisions, and some slight care in the lifestyle should be given to the baby postnatally. So these are the two categories, and critical CHDs are 25 percentage of CHDs, 20 to 25 percentage of CHD births, out of which are critical CHDs. There can be instances when the pregnancy, so medical supervisors advise to terminate the pregnancy, because even if the baby is born, it will not have maybe more than hours of life. So in those cases, there is no point in continuing the pregnancy, and it becomes an sorrow for the whole family. So in those cases, termination of pregnancy is uh, advised, which is called as TOPFA. And there is a very close relationship between prenatal diagnosis. Prenatal diagnosis, the diagnosis of disease that is done before the baby is born. So that is prenatal diagnosis. So prenatal diagnosis and the number of live birth. Live birth means the total number of babies who are born life, that is number of live births. So there is a very close relationship between the prenatal diagnosis and the number of live births. And when it comes to the ultrasound scan, even though the country is developed or underdeveloped or developing countries, definitely the minimum facility for an ultrasound scanning will be there. And this could be ensured, not much facilities, not much technical advancements are required for diagnosing CHDs. So within the given situation, if it is being carefully handled, the diagnosis rate could be improved. So this is the basic introduction about the topic, and some of the statistics I would like to show is the prevalence of CHDs. So the graph shows, the country wise there are some sample countries taken, and country wise the occurrence of CHD prevalence has been shown. So Republic 30.9 per 10,000 prevalence is there, and in case of the total number of babies who are born, and when it comes to only the live birth, 21.3 are still having CHD. So this is the statistics. So this will prove that this is one of the major one of the common anomalies that can be observed. And as I said, there is a very close relationship between the prenatal diagnosis and the live birth. So here, country wise prenatal diagnosis percentage, this is not all over, some tertiary clinics have been taken and the percentages have been arrived. So the country wise prenatal diagnosis and the live birth, as I or the TOFA can be applied, the number of live birth is directly proportional to the prenatal diagnosis. That is, this statistic is showing. And the problem statement is the major factor, scary factor is only 50 percentage diagnosis rate is there globally. Around 50 percentage only diagnosis is happening for CHDs. So that there are several reasons for that. The major reason is technical limitations. If you watch the underdeveloped countries and the developing countries, there can be technical limitations, technological limitations might be there. The health centers might not be sufficiently available, and the medical supervision is not available. In that cases, the diagnosis can fall down. But even in developed countries, even if it is diagnosed, the due next stage to the next phase, that our outcome is not going to the next phase of the treatment. So that kind of incidents are also happening. So this technical limitations could be the first reason. The second one is the expertise. Normally, for clinical practitioners, experience matters a lot. So during when they see different cases, different patients, different behaviors of fetus, based on all these things, the observation need to be time taking. Observation need to be done with a lot of care and alertness. So expertise is another thing. Even though the person is expert in radiology and sonography, need not be the appropriate. Patient to patient it may differ. The angle the device is being kept, the position of the baby, if the suppose the baby is not in the right position to observe the heart, then the practitioner should ask the mother to go for the time being and come after some time, so that the baby is available in the right position. So expertise is very important. And then time constraints, and the time the practitioner is spending with the patient is very important when it comes to the fetal cardiac anomaly detection, because it will take a lot of time to record the different angles of the heart, so that correct angle images are being recorded, and from that diagnosis, manual diagnosis can happen. So if the images are not available, definitely it will be restricted to only few images, and based on that the anomaly might not be very relevant. And since the heart anomalies are very minute, it needs a lot of concentration and presence of mind to get it noticed. So this could be the problem statement, and the objectives are to overcome these problems. The objectives are to suggest the CHT diagnosis, automation of CHT diagnosis using ultrasound scan images, and the second objective is to design a system for diagnosis using artificial intelligent model. And these are the most relevant literatures I have referred to. These are some sample only. So the two categories I have referred to, different categories of literatures. The first category of literature falls as the research is done by the medical practitioners, where uh, they have found the importance of relevance of prenatal diagnosis of CHTs, and how exactly the prenatal diagnosis is going to contribute towards the live birth and the and a healthy baby, uh, postnatally. So these are some of the very relevant and latest literatures sample. So that is the first set, and the second set actually consists of different artificial intelligence models that has been used for some other purposes, like breast cancer diagnosis, to check whether the tumors are malignant or benign, and thyroid nodule identification. All these some similar principles are being used, and since it has been, all these works have been done, implemented using ultrasound scan images also, and artificial intelligence models have been working out very well. It has been proved in the models. So these are the two set of categories of literatures I've reviewed. The methodology I suggest is to for diagnosis of CHDs, congenital heart diseases. The two different views. There are two views of our heart. So the first view is the three vessel view, and the second is the four chamber view. So these two views are very important while diagnosing any heart disease. So even for CHDs, these two views can be used, and these two views will tell you whether the heart is normal or abnormal. Is there any structural deformalities? All these things could be found out from these two views. So the methodology suggested is to develop a model which can be trained using the labeled images initially, where normal heart images along with the abnormal heart images with labels could be given for training. And once the model is trained, it could be used for clinical observation. So if it is giving good results, then could be used for further processing. So some of the results from the literatures I've observed, these are some 17 CHTs that normally been observed in different fetuses, and different papers have been mentioned, written related to the different CHDs. And the major work here is the results accuracy obtained by different models. Maybe it is for working, the working will be based on different organs and different findings, but still the technology, same technology could be used for finding the CHDs as well. So some observations I've made is, the first paper, for example, is for done for breast ultrasound image classification, for finding whether the tumors are benign or cancerous. This is simple CNN models have been used, but still showing accuracy of 91%, and it is a very recent study that has been published. So these studies actually will put a light on how exactly the models could be implemented on ultrasound scan images in the context of CHDs as well. The conclusion is with the how exactly the accuracy plays the major role in cardiac anomaly diagnosis. Why it is important? It is very much important that diagnosis needs to be done, and the diagnosis that we are doing should be accurate. So definitely, if an automated system is being implemented, that would be, if it works, goes on a hybrid mode, so that responses from the automatic system also could give put a light on what the sonographer is finally diagnosing. And the compromise on the prenatal diagnosis may result in huge tragedy by losing many number of lives, and not properly giving appropriate medications at the time of birth. All these could be an impact of compromising on prenatal diagnosis. So these the all the literature uh, um observes the same thing, and the possibilities are being explored. What exactly could be done for correcting the existing system. So there's a similar model as shown in the previous result table. Similar models could be implemented, and these models could be trained with images, ultrasound scan images with CHTs and without CHTs, so that live clinical trials could be done to identify the accuracy of the algorithm. And if it is being done correctly, it would be very revolutionary. If the percentage of diagnosis from 50 percentage, if we could move it to at least 60 percentage, it would be revolutionary. The future scope is, once the classifical model is ready and the test, it could be done, sent for clinical trials, and once it has been approved, that could be implemented in the ultrasound scanning machines. It could be embedded in the ultrasound scanning machines itself, so that the diagnosis results could be acquired from the machine directly. And the major challenges that is going to prevail is the availability of the ultrasound scan images, as there are so many ethical issues, existing ethical issues. The healthcare centers might not provide the images very easily. Since there is no existing database, standard database is not available for this, this could be a challenge for the research. And also, once it is the once this first challenge is overcome, and if even if the algorithm is been available for implementation, the embedding of algorithm into a machine could be challenging. And these are the references, some major references I have used. Thank you so much. Have a good day. Thanks for the patient listening.